Today we're going to look at other right triangles that we can use and look at, and applications of those. So we want you to be able to apply properties of two special right triangles, and also calculate and apply angle of elevation and angle of depression type problems. Two special right triangles that occur a lot in geometry, just in architecture as well, is a 45, 45, 90 degree triangle. Basically, this occurs when you take like a square and draw a line from corner to corner. Okay, it basically cuts a square in half. So if you would cut these corner right angles in half, that makes them both 45 degrees. So you end up with a 45, 45, 90. Our right angle here is our 90 degree angle. We know then anytime we're in a 45, 45, 90 degree triangle, you're going to have two angles the same. And in geometry, you talked about anytime two angles are the same, the two legs associated with those are also going to be the same length. It's an isosceles triangle. So knowing that those are both the same, we would also be able to call this side x. So if we have x, x, for those two sides, they're going to be the same. We want to find now what is this last length, the length of the hypotenuse. Well, we know from before we can find hypotenuse of a right triangle by doing a squared plus b squared equals c squared. So here we're adding two sides squared that are the same. X squared plus x squared is 2x squared. Okay, if we keep solving for c now, the last thing we would need to do to undo this power of 2 is to square root both sides. So our missing side c ends up being the square root of 2x squared. We could take that square root now and split it into two separate things. We could say it's the square root of 2 times the square root of x squared. Square root of x squared, we know from previous work working with radicals, is that that would just equal x. So this missing side over here is the square root of 2 times x. So anytime you have a special right triangle, and write this down in your note sheet, these two sides are always going to be the same, and the hypotenuse is always whatever that is times the square root of 2. So we're going to use that to find some different values and get some exact values when doing it. So in this problem, they want us to figure out what's the missing side of x here. Well, we know if you see a 45 and a 90, knowing that triangles have to add up to 180, that automatically is going to make this 45 degrees, meaning these two sides are the same length. If you want to find the missing side now, you could, again, just actually use Pythagorean theorem with the values given, or another way you could do it, well, let's do that first. 4 squared plus 4 squared equals x squared. This should work out. That'd be 16 plus 16 is 32. And we could take the square root to get it. Looks like it ends up being square root of 32 is the length of that long side. Our little trick, though, says if we know how long this side is, our value of x here is whatever these other sides are, 4 in this case, times the square root of 2. So another way we could write it is that x here is 4 square roots of 2. Now, why isn't this the same as this? Well, it actually is. If we just do a little simplifying of our radical over here, we should get the same thing. 16 goes into 32 2 times. And we know square root of 16 is 4, so square root of 32 does actually equal 4 square roots of 2. So the exact answer here, or the simplified radical version of the answer, would be 4 square roots of 2, is how long that is. All right, let's try another one. Number 2 here. What's this one going to equal? Well, again, it's a 45, 45, 90 triangle. We know that because these two sides are the same, meaning these got to be the same angle here. Now this time we know the hypotenuse, and we want to go to one of the shorter sides. So we don't want to times this x by square root of 2. We actually want to go the opposite way. So instead of multiplying by the square root of 2, here x is actually going to be whatever this side is divided by the square root of 2. So x in this problem would be 5 square roots of 2 divided by square root of 2. Because before we would multiply, if you're going the opposite way, opposite of multiplying is to divide. If we got square root of 2 over square root of 2, those cancel out. Here, both these sides are a length of 5. And it would make sense, right? If we then times 5 by square root of 2, we would get our hypotenuse value. So for number 2, the answer would be 5. All right, let's try one last one here. Why don't you pause the video and see if you can figure out the answer to number 3. All right, let's see what you got. Looks like on this one, another 45, 45, 90 triangle because we got two sides the same, meaning two angles the same. Here we know the bigger side. We're going to a smaller side, which means you would not want to multiply by square root of 2. You'd actually want to divide by square root of 2. So this is going to be 12 divided by the square root of 2 for the answer. That answer's okay. One thing you need to be able to do, though, if you go on and take like the ACT test, is this answer that we just got is exact, but it's probably not the one you're going to see on the multiple choice answers. Because a lot of times on the ACT, they don't like leaving radicals in the denominator. So you can simplify that by always multiplying by the same radical. So if we multiply this by square root of 2 on the bottom, that means we also got to multiply square root of 2 to the top, because whatever we do the bottom, we have to do the top to keep it the same. We can get another answer that looks a little bit nicer. So on top, if we multiply across, we got 12 times the square root of 2. And on bottom, we got square root of 2 times square root of 2, which is the same as square root of 4. But we also know square root of 4 is just going to equal 2. So now we got 12 square roots of 2 over 2. Well, does 2 go into 12? Yeah, 2 goes into 12 6 times, and it goes into itself once. So a nicer way of writing this answer would be 6 square roots of 2. That would probably be the answer you would see on one of the multiple choice answers on the test rather than this one, although they're both exact answers. Okay, another popular right triangle that shows up a lot in geometry and again in architecture is this triangle, a 30, 60, 90 triangle. And the reason this one shows up a lot is because it's associated with an equilateral triangle. Equilateral, remember from last year, is when all the sides are the same length, okay? Because that's a triangle that has all 60, 60, 60 degree angles. Well, a lot of times, if you want to find like the height or something of an equilateral triangle, what you end up doing is drawing in the height right down the middle here. This is the height. And so it splits the angle into two other angles, two equal angles, being 30 and 30, which add up to 60. So half of this is a 30 degree, 60 degree, and we got our right angle here, so 90 degree triangle. We want to figure out what could we do to find these other lengths. Well, if it's an equilateral triangle, we know if this side is called 2x, that means this side's 2x, and this whole length down here is 2x. But when we draw on this height, we not only split that angle in half, we also split this length into two equal pieces. So what would the length of each one of those be? It would be half of 2x. Well, what's 2x divided by 2, or half of it? A single x. So both of these would be x and x. X plus x equaling 2x. Okay, so now we got this triangle where we know it's a 30 degree, 60 degree, 90 degree triangle. This side we're calling x. This side we're calling 2x. What is this third side going to be? Well, again, anytime you know two sides of a triangle, you can find the missing one by doing a squared plus b squared equals c squared, our good old Pythagorean theorem, and finding that out. Here our hypotenuse is the 2x. That's going to get squared there. We have another side we're calling x. We don't know the third side. Let's call that a right now. So what is a going to equal? Well, if we square 2x, it means we got to do 2 squared and x squared. 2 squared, 2 times 2 is 4x squared. Now we need to subtract this term over to the other side. That's a 1x squared. So now we have 3x squared. And then finally we need to take the square root of that. Which means we got two things under the square root there, square root of 3 and square root of x squared. Well, we know square root of x squared is just x. So the third side of this right triangle is whatever this side x is times the square root of 3. That's always what you're going to get when you have a 30, 60, 90 degree triangle. So notice some things here. The shortest side, whatever that is, the hypotenuse is double. It's twice the length or double the short side. And then the longer leg is square root of 3 times bigger than the short side. So we want to use that to help us kind of quickly get to the missing sides in any 30, 60, 90 degree right triangle. So on number 4, they want us to figure out what are the two missing sides here. Well, let's find the short side. That's the short side. Here's our hypotenuse. So what did we say about the relationship between the hypotenuse and the short side? This hypotenuse is twice the length of the short side. Well, if we're going to go then from a long side to a short side, we would do the opposite. Instead of dividing or multiplying by 2, we would divide by 2. So in this one, x is going to be 10 divided by 2, or 5. So in this one, that short side should have a length of 5. The longer leg we looked at has a multiplication of square root of 3 when going from the short to long side. So we want to use that to help us quickly find this one. Y then is going to be our short length 5 times the square root of 3. And there's not really anything we can do to simplify that. That would be the length of y. Now, just to show you that these do in fact work as well, you could do trigonometry to help you do these as well. All that trig stuff we talked about should still apply. For example, on this one, get your hypotenuse, and if we're using the 60 degree angle, that would be our adjacent side. We could set up a trig thing to help us do the same thing. 60, and it would be cosine here because we got adjacent hypotenuse, would be adjacent side over hypotenuse. If we multiply both sides by 10, we got 10 times cosine 60. Watch what we get when we put 10 cosine 60 in. 10 cosine 60. It equals 5. Same thing that we got right here. Now that works sometimes. That's an exact answer, but other times when they ask us to find the exact answer, trigonometry doesn't work so well. And it doesn't work in the case when we want to find the exact answer for y. Because if we were finding y, that's the opposite side, we would use sine 60 equals y over 10. So y is 10 sine 60. When we put this one in, not as nice. 10 sine 60. And we do find out that it is about a length of 8.66. But that's not an exact answer. That's like a rounded off answer. 5 square root of 3 is the exact same value. It's just that that's written as an exact value. See, you can see that both of these are exactly the same. So sometimes this is going to be okay to get the answer of it's about 8.66. Okay, sometimes that's okay, but if they ask for the exact answer or the simplified radical answer, you need to be able to come up with that. ACT does both. We want you to be able to do both as well. All right, let's try another one here. On B. Okay, what is the missing lengths here? Okay, 30, 60, 90. Again, you can see the angles written in there. Okay, so we want to look. Okay, what side do we know? This is the longer leg. It's not the hypotenuse. The hypotenuse is always across from the right angle. So if we know the longer leg and we want to go to the shorter leg, that's a factor of square root of 3. Since we're going from a longer side to a shorter side, we don't want to times by square root of 3. We want to divide by square root of 3. So x here is going to be 12 divided by the square root of 3. That's one way you could write the answer. If you got radical in the denominator, though, remember how we talked about we can multiply by that same radical. So another better way to write this answer would be 12 square root of 3. Square root of 3 times square root of 3 is going to be square root of 9, which we know equals 3. And then 3 does go into 3 once, and it goes into 12 4 times. So probably the way you'd see this written on the ACT would be 4 square roots of 3. That's the better way to write that one. All right, well, we still got to find y, though. Okay, now we're going from the short side to the hypotenuse. That's a factor of 2. Since we're going from a shorter side to a longer side, we want to times by 2. And so y here is going to be 2 times whatever our short length was, which was 4 square roots of 3. So the exact length of the hypotenuse is 8 square roots of 3. So those would be the two there. Let's try one more of these here. Looks like, oh, nope, that was it. Let's go to the back. On the back, we are now using some other things to find some exact values. So they're either going to be asking you something with a 30, 60, 90 or a 45, 45, 90. First one looks like 45, 45, 90. Find the exact value of sine 45. Well, over on our picture here, both of these angles are 45, so we could pick either one. What two sides does sine use? Well, we know from our saying sine is opposite over hypotenuse. So what is the opposite of hypotenuse on this one? Opposite side would be here. Hypotenuse would be here. So the exact value of sine 45 is going to equal x, our opposite side, over our hypotenuse, which is x times the square root of 2. Well, if we have x on top and x on bottom here, what we can do is cancel those out. And so we want to, so we cancel these, and what we have left then is on bottom square root of 2. On top, we canceled that out, so we got to put something. In this case, 1x, anything divided by itself is 1, so it'd be 1 over the square root of 2 would be the exact answer. Again, if the test doesn't have that one, it's probably because they multiplied by the same square root on top and bottom again. And so another way you could write that as well is 1 times square root of 2 is square root of 2. On bottom, square root of 2 times square root of 2 is 4, square root of 4, which we also know is 2. And so either one of these might be how you see the answer written on the exam. All right, second one, find the exact value of tan 45. Okay, tangent, SOHCAHTOA what is opposite over adjacent. Over on our picture here, we got opposite and adjacent side. They're both x. And so on this one, tangent 45 is going to be x over x. Well, anything divided by itself is just 1. The answer to this one should be 1. You can even double check this one on your calculator very easily. Tangent 45 equals 1, because you're always taking a ratio of the same length over the same length. All right, let's try a 30, 60, 91. Here's a 30, 60, 91. On these triangles, your 30-degree angle is going to be opposite the shorter length. Your 60 is here, the bigger angle. And so sine 60, okay, we want to find what's our opposite side and our hypotenuse would be those two. And so sine 60 is going to be the opposite side, x times the square root of 3 here, over the hypotenuse, which is 2x. Our x values again cancel, leaving us with square root of 3 over 2 is the exact value of sine 60. All right, one last one, tangent 30. Now you got to be careful here. Now they switched us to the 30-degree angle. So our hypotenuse won't change, but our opposite does. The side opposite our 30-degree angle is now this one, which changes this to our adjacent side. Adjacent side and opposite side always depend on which angle you're using. And so tangent of 30 is going to be our opposite side, which is x, over our adjacent side, which is x square root of 3, again, x's cancel, and so the answer would be 1 over the square root of 3. Or if we times by square root of 3 over square root of 3, that would also equal square root of 3 over 3, would be another way of writing that. So if they ask for exact values, that's what these special right triangles can provide us. Next thing we're going to look at is angle of elevation and angle of depression. Angle of elevation is where you have somebody and they're observing something elevated from where they are. So in this diagram here, this air balloon has a height up in the air. This person's sight line from where they're at creates an angle that we call the angle of elevation. That angle, then we could use some of the trigonometry stuff that we've been talking about. A different situation is where you have someone higher up than where they are looking. So in this one, this person standing on the building, if they were looking horizontally straight ahead, the amount they have to rotate down to see an object below is called the angle of depression. One thing that we should notice with these two angles is, say there was somebody else down here looking up at this person, there's an angle of elevation as well. These two angles are actually always going to be the same, because if you recall from geometry, if you have two parallel lines, which we would have with the ground and this person looking straight ahead, alternate interior angles are what we have here, and they're always the same degree. So say this was 50 degrees, then this angle would also be 50 degrees. So the angle of elevation and angle of depression should be the same when doing these problems. All right, so let's look at a problem here. It says a tree casts a shadow 25 feet long. The angle of elevation from the tip of the shadow to the top of the tree is 64 degrees. Find the height of the tree. If you get problems like this, and they like to give these types of problems on like the ACT, sketch out a little picture, it doesn't take you very long, of the shadow, okay? And they said the shadow is 25 feet long. That's on the ground here. There's an angle of elevation, mean angle looking up to the top of the tree right here that they say is 64 degrees. How high is the tree? So here's our tree. That's what we want to find. That's our x. And the tree and the ground create a right angle. So we have a right triangle that we now can use and find this missing amount out using some trigonometry. So just like we've done in previous problems, hypotenuse, opposite, adjacent. Looks like we're not really concerned with the hypotenuse in this one. The one that uses O and A is tangent. We always put the angle right after. Equals, and tangent is always opposite over adjacent, so x over 25. Now we just have to solve this out like we did before. To get x by itself here, we want to multiply both sides by 25. These cancel. So x is going to be 25 times the tangent of 64. Hop on your calculator. Really easy to get the solution. And this is not one where we need to get an exact answer, because 64 is not one of the 45, 45, 90 or 30, 60, 90. It's a different angle. So we're okay here just getting an approximation. It appears that this height is about 51.3 feet. Approximately. It's not exact, but pretty close. Let's try another one here. Number 10, when landing a jet will average a 3-degree angle of descent. What is the altitude? Altitude's another name for height, to the nearest foot of a jet on its final descent as it passes over an airport beacon 6 miles from the start of the runway. Again, let's get a little picture here. Okay, so we want to find the height. They talked about that. What is the height? What's the altitude? It passes over an airport beacon 6 miles from the start of the runway. So over here is where the runway starts. What's the angle of descent? Now, a common mistake in this problem is to draw it out here, and we got our right angle, and this is where we put the 3 degrees. That would be incorrect in this case. That is not the angle of depression here, because remember how we talked about before, the angle that we're looking is if this pilot's looking straight ahead, How far do they have to rotate down to the ground to see that runway? That's our 3 degrees. Okay, this would be like 87 degrees here because those two would have to add up to 90. So you could use that angle of 87, but just make sure you use 87 and not have this be 3. Because remember, we also said this angle then should be 3 degrees as well because they're alternate interior angles. So now we want to solve this out. You could either use this top triangle or the bottom triangle. They're both the same. Either one's fine. In both cases, our opposite side is x. Our adjacent side is the 6 miles. Now, the other thing you got to notice in this one, which is kind of tricky, they could throw something like this at you on the ACT. They want the answer to the nearest foot. Right now, our length is in miles. We need to do a conversion here. Okay, we talked about conversions earlier in the year. So we got 5 miles, or sorry, 6 miles, 6 miles over 1. Our conversion for miles to feet is 1 mile. We won't put miles on bottom so that our miles cancel out here, equals 5,280 feet. So we need to take 6 times 5,280 on this one. And so it looks like we want, instead of using 6 miles down here, that's also the same as 31,680 feet. Okay, again, now this is just a trig problem. We should be able to set it up and solve. So we got opposite and adjacent. That's, again, tangent of 3 degrees equals opposite, we don't know, over adjacent, which is this amount. Multiply both sides by 3160, and we should get the answer. And if you type that into your calculator, turns out that the altitude is about 1,660 feet. All right, last one here. Why don't you pause the video, try this one on your own, and see how you do. All right, let's see how you did. Some kind of picture like this would work. You got the height of the tree is 50, the shadow 60, and this one they're actually asking for the angle. So let's see how you remember to do those ones. It is opposite and adjacent again, which means this is a tangent problem. Tangent of what angle we don't know right now equals opposite over adjacent. This one, don't times by 60. We got all the numbers over here. We need to get x by itself. This is one where you got to move the tangent over. And when you move the tangent over, recall that it turns into inverse tangent. So now in your calculator, type in inverse tangent by hitting that second button of 50 divided by 60. Hit equals, and it should tell you the approximate angle. Looks like it is very close to 40 degrees here. So x is approximately 40 degrees. Okay, try some of these out now on your own.